Here's the initial inspection of the Gibson BR-9 amplifier. You can see she's pretty crusty and dusty looking. The speaker is torn and the voice coil drags. So the speaker itself is shot. So I've already lined up a Jensen replacement. Let's take a look bottom side. Alright, here is the bottom side of the Gibson. You can see she looks pretty much 100% original. I don't see any signs of past maintenance. Still has what they call the old toilet paper roll filter cap. This little guy here is the interstage transformer that goes to the two 6v6s. There is no inverter tube, so don't pull that out and be careful working around it because it's very pricey to replace. Still has all those old paper caps. It's all coming out. This thing needs a complete recap and obviously a new speaker. So I thought, as a precaution, since I know how fragile this interstage transformer is, I better buzz this thing out first. Let me show you on the schematic how this transformer operates and then we'll measure it. Here is the interstage transformer on the schematic. In a typical guitar amp, there would actually be a tube here which provides the inverter function. But back in the day, they used a transformer. So your signal comes in here off of the 6SN7 and hits the primary. And then it goes into this transformer which splits it. So one half of the signal goes to this 6v6, the other half goes to this one. And if you look at this, you'll see there is a center tap right there to ground. So you can take an ohm meter and go from ground to each of those pin 5s and you should see a high resistance. If you don't, we have an open winding and one of the 6v6s will not amplify. Let's test the amp. Here we go. We're going to buzz out the interstage transformer. I'll start with the primary, which goes from a high voltage feed to the 6SN7. You see we got about, say, 578 ohms, so the primary is live. Now we're going to check the secondary, so I'm going to take one lead, put it to ground, and those secondaries go to pin 5 of the 6v6 tube. So here is one of them. See, we got a little over 1,000 ohms. The other one is over here. And looky there. We're open. Unfortunately, this is a very hard part to find, so now I've got quite the task ahead of me to locate one. So if you have to change one of these field coil speakers with a standard modern speaker, there's two things that need to take place. You've got the field coil, which is the electromagnet of the speaker, plus it is the power supply choke for the amplifier. So you'll have to add a choke onto the chassis of the amp. Then you have the output transformer, which is bolted right to the speaker. This will also be relocated to the chassis. But first thing you need to do is determine the impedance of the speaker. To do that, you have to disconnect the secondary winding of the output transformer so that you can measure the voice coil of the speaker itself. So I have this lead lifted. Next I'll take my ohm meter and we'll check the coil and find out what the resistance of the speaker needs to be. I got my meter right down on those voice coil terminals, seeing approximately 3.6 ohms. So this is a 4 ohm speaker. To replace it, I'm going to install a Jensen C8R-4 ohm. Alright, this is the initial test of the Gibson BR-9. I just want to ensure that I can at least get some audio out of this thing to verify the power supply is operating. So we're going to bring her up very carefully on a variac and watch the current. I got a looper hooked up for the input. I'm up to about 70 volts. So there's a lot of hum even with the volume control all the way down, so it's obvious the filter caps are bad. But the good thing is the amp does power up, so now I can proceed with the repair. I removed the old crusty filter capacitor, and by recommendation of Dan out there in Patreon land, he said, hey, why don't you put in a Cub 1 board to replace that multi-section cap? I thought, what a great idea. So it is installed. And now what we're going to do is test the power supply all by itself. So I have removed the 6V6s, and in their place I'm going to be using a 20K 25 watt resistor that is strapped across the power supply. I'm going to bring this thing up on the variac and we'll watch the DC voltage on the meter. In case you're wondering how I came up with the value for a load resistor, remember I said it's a 20K at 25 watt. What I did is guessed that I would be at 400 volts DC. Alright? Then I said, okay, I'm going to apply a 20K load. So you divide 400 by your 20K, that comes up to 20 milliamps. And then I said, okay, 20 mils through that resistor, so we're going to times that by the 400. That's 8 watts of dissipation. So this guy won't go up in a puff of smoke. Here we go with the power supply testing using the load resistor. To control the testing, I'm using a variac. So I'm going to bring it up. There's about 50 volts and I'm watching my current. And you can see our voltage is coming up on the meter. Here is 100 volts applied. And we're at around 383 volts. If I were to plug that right into the wall, it'd probably jump up another 20 volts. I used 450 volt filter caps. And that is why you have to be careful if you put in diodes, because you're going to lose the inherent loss of the 5Y3. But it appears as though this power supply is working great. It's time to continue with the repair. As I told you earlier, one of the windings of the interstage transformer is open. So I'm going to replace that with this new old stock universal one that I found in my stash of hanger queens. Then, of course, while I was getting ready to do that, I thought, you know what, I better check the output transformer for the 6V6s. And here he is. And guess what? One of its windings are open too. So, I've already replaced that with this old Utah 5999 output transformer rated at 12 watts. It's mounted on the chassis. So now, I can get under here and put in the interstage and see if this thing will try to work. Well, here's the crazy setup, guys. I've got that interstage transformer just tack soldered into place. We have a looper hooked up for the input. I'm going to be monitoring the current through the 6V6s. They have a 200 ohm biasing resistor on the cathode. I'm going to bring this thing up carefully on the variac, monitoring for smoke. Okay, it's powered up. Try to get that glare off my meter. Got the volume halfway. Here comes the voltage across that resistor. Look at there. I'm only running at about 75 volts right now. Play too long because I want to make sure that bias voltage is okay. Don't want to overdrive the 6V6s, but the interstage transformer is working. The BR-9 lives again. Super cool. Alright guys, there it is. Interstage transformer is installed, wired up. Got a new filter cap board assembly. We have our new old stock Utah output transformer. And these taps, you start at 1 and there's multiple taps for different impedance speakers. So the first tap here, which is terminal 2, is 4 ohm, 8 ohm. I didn't test the others. We're going to be running a 4 ohm speaker with a Gibson. So there's hope. This thing is looking good. Alright, now we are going to measure the current through the output tubes. This amp is cathode biased using a 200 ohm resistor. I just need to see what this current level is, and then we'll adjust it as necessary. I expect it's way too high for the 6v6s. So I see 19 volts. Alright, we'll just call it 19.5. Alright, we'll check that on the calculator. So we have 19.5 volts divided by 200 ohms. That's 97 milliamps total. If you divide that by 2, that's 48.7 milliamps per tube. So that's really running those 6v6s hard. I'm going to be changing out the 200 ohm bias resistor. I've already landed a terminal board, so we'll get that off of there and adjust the bias and get those tubes under control. Alright, here is the easy non-scientific method for adjusting the cathode resistor and setting the current on your output tubes. So you're going to have a milliamp meter in line with the cathodes of those tubes. So remember, initially we had a 200 ohm resistor. We're pulling way too much current. I want to half that current, so I'm going to target around no more than 30 milliamps per tube. So since we had a 200, let's put a 400 ohm in series. Okay? So now the milliamp meter is hooked to ground. It passes through the meter, goes through the resistor, and then to the cathode of the tube. Alright, let's plug it in and see what we get. Okay, the amp is plugged in. We are now drawing current through the new 400 ohm resistor. DC milliamps going through those output tubes. Now remember, this is both of them. Somewhere around 65 milliamps total, so like 33 milliamps per tube. Okay? I'd rather go under that a little bit. So let's put in a 470 ohm resistor and repeat the test. What's nice about doing it this way is you're actually seeing the live current through those tubes. You don't have to calculate it. Now I've got a 470 ohm resistor in series. See, we're under 60 milliamps, so that's under 30 milliamps per tube. I'm going to go with that. Alright, we have this Gibson BR-9 amplifier with a pair of new old stock GE 6v6s installed, and this amp is suffering from noise, that static crunchy popping that you hear. Let's take a listen to it. Even if you tap on the tubes, it does not excite the noise. So now let's install a pair of Electro-Harmonix 6v6s and see what it does to that noise level. Now we're going to install a new set of Electro-Harmonix 6v6 GTs. Repeat the test. The amp is on. There's my volume. The old lightning bolt crunchy noise is gone. So even though these GEs were a new old set of tubes, they had problems. The Electro-Harmonixes will remain with the Gibson. Here's the test of the Gibson BR-9 I recently added a speaker jack. This is RCA jack that feeds the 8-inch Jensen 4-ohm speaker. Going to use a looper here, see what she sounds like. Here she comes. Of course, that speaker is going to sound much nicer once it gets installed into the cabinet. But she's crisp, she sounds good, and there's no smoke.